So, we are discussing about some notations and terminologies that is required to understand the concept of fuzzy logic. So, few terminology we have discussed in the last lecture, and today we will continue the same discussion. We will discuss few more terminology, and so first is called the fuzzy singleton. So, if a fuzzy set consists of only one element whose membership value is exactly 1, then such a fuzzy set is called the fuzzy singleton. For example, here this is the one fuzzy sets, all the elements having the different membership values, but there is one element whose membership value is this one is basically 1, then it is called the fuzzy singleton. So, fuzzy singleton is like this, and now we will discuss about another two important terms. It is called the alpha cut and then strong alpha cut. The alpha cut of a fuzzy set, it is denoted as A alpha, A suffix alpha, it is denoted as alpha, A suffix alpha. The alpha cut is basically the creep set X, set of elements say X, such that the membership values of this element is greater than or equals to alpha, where alpha is a predefined values, and need not is to say that alpha is basically a value in between 0 and 1 both inclusive. So, for example, A 0.5, if I say like this, that means it is basically the crossover points, and set of all crossover points that belongs to the set A. Likewise, the strong alpha cut, the difference between the two is basically greater than equals, and in case of strong alpha cut it is basically greater than symbol, otherwise they are the same. So, we can easily understand that a support that we have discussed about is that A 0 complements is basically complements, and complement means other than the elements which belongs to 0 is a complement. We will discuss about the complement is just like a set complement, inverse actually, and similarly we also can say core A same as A 1 from the previous discussion that we know. So, it is like this. So, core A is basically the alpha cut where alpha equals to 1. Now, we can define another term is called the bandwidth of a fuzzy set A. It is basically the difference between the two values of the element, namely x 1 and x 2, such that x 1 and x 2 both are the two crossover points. Obviously, if there is a fuzzy set which contains more than two elements at the crossover point, then the two extreme crossover point can be used to decide their bandwidth. So, bandwidth is basically the difference between the two extreme crossover points x 1 and x 2 like this. Now, we will discuss again a fuzzy set as a symmetric or asymmetric. We define a fuzzy set as symmetric with respect to one element x equals to say, such that all membership values for all the elements in this region has the same, and there is a corresponding elements having the same values. Alternatively or mathematically, we can say that if the two elements x plus c and x minus c have the same values for all element x that belongs to this set, then we can say such a fuzzy set as the Cripps set. In other words, Cripps set is basically a symmetric in form, but if we draw one, then this is not a Cripps set, because here some elements and all elements may not have the same values like this one. So, this is the concept of symmetric fuzzy set, and the next is basically open and closed fuzzy sets. Now, here this is the one description of fuzzy set, we can say open left. Now, we say the open left a fuzzy set is if it satisfies this definition. Now, we can say for the open left all elements which is beyond the x tends to minus infinity this side is equals to 1, because it is basically 1, and limit x tends to plus infinity after this point is basically 0. So, there are two extreme limits, this one where all elements is 0 and here all elements is 1, then such a fuzzy set along within this portion is called open. Similarly, we can write open right here all elements which x tends to infinity is basically 1 and here all elements which x tends to minus infinity is 0. So, this definition it is called the open right. So, open left and open right. Similarly, the closed, if we say for all element x tends to minus infinity and all element x tends to plus infinity, if there the value is 0, then all this is basically called a fuzzy sets and this type of fuzzy set is called the closed. So, there may be three different form of a fuzzy set, either open left or open right or closed. So, any fuzzy sets can be belongs to this category only, either open left, open right or closed. Now, one thing just we want to clarify it is here, and is there any link between fuzzy and probability? Now, there may be certain what is called the link or relation, because if we see the fuzzy membership values is in between 0 and 1 both inclusive. Similarly, if we say the probability value of something, it also has the value in between 0 and 1 like this one. So, so far the values are concerned, both fuzzy and probability is synonymous, but there is a difference. Again all these 0.1 or some decimal in between 0 and 1 alternatively can be expressed in the form of a percentage. So, 60% is equal to 0.6 like this one. So, anyway, so the whether it is expressed in the form of a decimal 0 point something or it is a percentage, there is basically relation between the two things in that way, but there is a clear cut difference between the two. I want to clarify this difference between the two with an examples. So, first example, suppose a patient when come to the doctor and doctor carefully diagnose the patients and prescribe the medicine. Then what exactly the thing it happens is that doctor prescribes a medicine with certain certainty, let this certainty be 60%. This means that the patient is suffering from the flu and that he is sure about this is that 60%. In other words, so the disease for which he prescribed the medicine will be cured with certainty of 60% and there is again uncertainty 40%. So, this is the concept that is related to the fuzzy actually, it is the certainty or clarity or guarantee like. On the other hand, if it is the probability, then we can say that probability is also 60% or sort of things or 0.6 like. For example, India suppose will win the T20 tournament with a chance 60%. If I say so, it means that we have certain statistics or some previous experience that out of 100 matches India won 60 matches. So, 60% in this case and 60% in the previous case has the two different significance. So, in the first case, in case of doctor patient scenario, it is basically the certainty, and in the second case the 60% is based on the previous experience. So, certainty versus experience, this basically define the fuzzy versus probability. Now, likewise this fuzzy versus probability, there is another relation that is also related to this fuzzy and probability also, it is just in the form of prediction versus forecasting. So, fuzzy versus probability is also in many way analogical to prediction versus forecasting. Now, so we can say the prediction when we start guessing about something. So, it is a guess. So, fuzzy means it is a guessing power. On the other hand, forecasting means if we can say something based on the previous information or based on our previous experience. So, it is the forecasting. So, prediction, in other words, the prediction is based on the best guesses from the experts that basically who does it, and forecasting is based on the data which you are already have in your mind, and based on the processing of the data you can tell something. So, this is the forecasting. So, if prediction is related to fuzzy, then we can say the forecasting is related to the other, that means is probability. So, these are the things actually. So, sometimes we little bit get confused what about the fuzzy versus probability or like this one. Now, next our point of discussion is basically fuzzy membership function. We have some idea about it, and one thing I want to again mention it here, a fuzzy set can be described better in the form of a graph. That means, it is a graph versus all elements and their membership values. So, we can define in the form of a set theoretic form or in the form of a graph. So, in these slides we can see this is the one fuzzy sets and this is also another fuzzy sets. Now, the difference between the two fuzzy sets here is that here the elements which belongs to these fuzzy sets are having discrete values. So, there will be no element which in between 2 and 3 like. So, there will be no element there, but here is all elements in between the range 0 to 60 are belongs to this one. So, it is the element say 21 and it is the fuzzy set is there. We have also discussed about that the membership values can be discrete value also. So, here it looks at okay, all values are possible. So, here also the continuous values for all membership values, and here in also say it is also the continuous values of all membership values. So, that we have already discussed in the previous lectures that the membership function can be on a discrete universe of discourse or can be a continuous universe of discourse. The membership value can be again discrete values or it can be again continuous values. So, whatever be the values it is there, we have to express so maybe it is mathematically or using some graphical representation. So, these are the two examples where we can give the two fuzzy sets in the form of a graph. Now, I want to give more graphical representation of the standard sum fuzzy sets. So, these figures basically shows some typical examples of the fuzzy sets and they are defined in terms of the membership function actually, and these are the general looks that usually a fuzzy set takes. And in the first, this is the one fuzzy set, it is having the membership function in the form of a triangular shape. So, this is another fuzzy set whose membership function is expressed in the form of a trapezoidal shape. This is another membership function, it is basically curve, it is look like a bell curve. So, it is called bell function, bell membership function like, and it is the one membership function which does not have any specific shape, it is arbitrary shape, is called the non-uniform fuzzy sets, and this is also an example, it is also non-uniform fuzzy sets. However, it has some special meaning. So, this is the one fuzzy set, it is called the open left, this is the another fuzzy set is called the open right, and this basically called the fuzzy set closed. In this sense, it is also a closed. These are all the closed fuzzy set actually. So, these are the all closed or open. What I told you that either fuzzy sets can be open or open left, open right, or is a closed. Anyway, so these are the typical form of the fuzzy set which usually considered in our fuzzy system, in our fuzzy theorem. And another point is that how such a fuzzy set can be better described in some mathematical notation, so that we can process them in our future fuzzy system design. I am going to discuss these things, how a membership functions can be better mathematically described, and then that mathematical specification can be used to process in subsequent requirement. So, in this direction, first let us discuss about this is the one fuzzy sets or membership function, and this membership function, as I told you, it is a triangular membership function. So, usually this can be described mathematically using this triangle, and x is an element, and this membership function can be defined by means of 3 parameters a, b, c. So, 3 parameters are the 3 what is called the meaningful direction here, and in terms of these 3 parameters the membership function can be described mathematically using like this. So, it is clear that if x less than or equals to 0 a, so it is like this, then this is 0, and in between a and b the membership function can be defined by this. This is basically slope whatever it is. Similarly, in between this one, this is another slope, it can be defined like this, and so for the element x greater than 0, this one it is basically 0. So, what we can say, whatever the graphical representation which looks like this, it can be described mathematically using this form. So, this is a mathematical expression that a fuzzy set can be defined, and definitely this fuzzy set is defined over a continuous universe of discourse. Now, so this is the triangular membership function. Using the same concept, same idea, we can define the other membership function. For example, in these slides we can show the trapezoid the membership function. However, unlike triangular membership function, here we need the 4 different parameters, they are called A, B, C, D. So, these are the parameters are like here, and in terms of these 4 parameters we can define this membership function like the if x less than equals to A, it is 0, and if x is in between A and B, that means in this one. So, it is basically this one which can be expressed by this form, and in between B and C, this is the x. So, it is basically 1, and in between C and D, this is the slope which can be described by this one, and if x is greater than D, then this is 0. So, with this concept can be described in a mathematical manner, this membership function. Now, so this is the trapezoidal membership function. Triangular and trapezoidal are the two most frequently used membership function in fuzzy system in order to design a fuzzy system. The another important membership function that is more popular in fuzzy in order to describe a fuzzy system, and this is called the Gaussian membership function. A Gaussian membership function typically takes in terms of 2 parameters, C and sigma. So, is C basically is the middle point of this, it is called the centroid or mean, and sigma is defined is the range between these two, in between 0.1 C and 0.9 C. If C is defined here, then is 0.1 C and 0.9 C. So, this range is basically sigma. Anyway, so if we define 2 parameters like C and sigma, then this membership function can be better expressed in the form of a mathematic notation using this one. So, this basically the formula for Gaussian distribution. So, that is why it is called the Gaussian form, and if we plot this form for a given value of C and sigma and for different values of x, then the graph will look like this, as this graph looks like a bell shape. So, it is called the bell shape membership function also. So, this is the one popular membership function like this the membership, there are many more, and another is called the Cauchy membership function. So, it is just like a Gaussian membership function, but this membership function defined in terms of 3 parameters A, B, C, and using these 3 parameter how a membership function is defined, it is expressed here, and it has 2 characteristics here that it consider 2 points for the slope. So, slope at this point it is called the C minus A and another is C plus A. The slope of this point is basically B by 2 A and at this point is minus B by 2 A. So, if we define A, B and C, then all these values their slope and point can be defined, and accordingly the membership function can be defined. So, the membership function that can be defined using Cauchy membership function is this, and if we plot this membership function for a given the values of A, B, C, then the graph will look like which is shown here. So, this is the another popular Cauchy membership function, or it is sometimes is called the generalized bell. Now, this is a typical example of generalized bell for particular value of A, B, C, where A, B equals to 1 and C equals to 0. That means, it is basically C equals to 0 and these are the function, and if we plot these things, essentially if we plot this one, then it can give the curve like this. So, we can plot it and then we can have this curve. So, this is basically graphical representation of this one. Now, so there are few more membership function. Anyway, before going to these things, for the different values of A, B, C and whatever it is there. So, this membership function will look the different shape, and hence the different membership function or the different fuzzy elements can be defined. So, this is basically the idea about that membership function can be expressed in the form of a graph as well as in the form of some mathematical notation. Now, this is another very popular the membership function, it is called the sigmoidal membership function. A typical look of the sigmoidal membership function is shown here in this form. It is basically from the S. So, that is why it is called the sigmoidal membership function, just like a S. And this kind of membership function defined in terms of two parameters A and C, where C denotes the point, it is like this, and A is any arbitrary value, it is basically called the slope of this point at A. Now, if we take this kind of values, then the sigmoid function can be plotted, and if we follow this expression. So, if this is the expression, if we follow, then graph can be obtained for this expression for different values of A, it is shown like here. So, we can see here one example, if x tends to infinity, as is so, it is basically in this way is basically closed right, and in this case is basically open right, because for all values x which is greater than tends to infinity, the membership value is 1, and here for all values x tends to minus infinity, the membership value is 0. So, sigmoid is typically like this, and for the different values of A, the different curve will be obtained. For one value of A, the curve will be like, for another value of A, the curve will be like, for another is there, and so on. So, if we change the values of A, then different pattern of the curve will be obtained. So, what I want to mention here is that this is an important function which can have the different values of A and C, and the different membership functions can be obtained, and hence the different fuzzy sets, the different form of the fuzzy set, look of the fuzzy set also can be obtained. So, this is another membership function that is very much popular in the design of fuzzy system. Now, we can discuss one example, so that how these membership functions can be used. We are discussing about one idea about that how the grading in the form of a Cripps. So, these are the Cripps formulation of the grading, and here the same thing which can be discussed in the form of a fuzzy. So, another fuzzy representation. So, for example, the grade this one is 1 and grade is this one. So, these are the two different form. So, as we say, so this can be discussed with some function, and this kind of membership function can be discussed by means of say Cauchy MF or generalized Bell like. So, basically this membership function can be used to different what is called the fuzzy sets in the different range. So, this is the one fuzzy set in one range, this is another fuzzy sets, and this is another fuzzy sets like. So, we can use the same formulation for defining membership function in this case, other than these sets or other than these sets, these two sets can be defined either using open left or closed left with another membership function, but all the other membership function in between the range, and they can be defined in terms of some graph or in terms of some mathematical notation, say Cauchy membership function like, and then they are basically called the different fuzzy set. For example, if we define one membership function in this form, we can say that this is the bad fuzzy set, where the universe of discourse is this one and the elements belong to this is this one. Within this element, up to this the membership elements value is 1, and after this thing membership value is decided by this what is called the function. Similarly, the another membership function like this one, it can be defined in terms of this is the universe of discourse, and the elements is in between. For all elements it is 0, for all other elements 0, and in between this the membership value will be decided by the type of the curve. So, these are the basically the way which we can use to define the membership function for the different elements. So, we have understood about the different membership functions and their mathematical representation. We will quickly cover a few more concepts about the membership function. The two concepts, it is called the concentration and then dilation. So, the idea is that if A is a fuzzy set given to you, right, then we can define another fuzzy set. Let this fuzzy set be a k, where k is some value that may be greater than equals to greater than 1, such that this mu a x to the power k is the new membership values for the element x which is belongs to the set a k. So, this means that if A is known with mu a x is the membership value, then we can derive another fuzzy set a k with membership value this one, and for k greater than 1, if it is like this, then it is called the concentration. Similarly, if it is k less than 1, the same thing if hold goods, then it is called the dilation. So, this is a very important concept, that from a given fuzzy set we can find more fuzzy sets, many more fuzzy sets. These fuzzy sets can be obtained by simply using some mathematical notation like this, concentration or dilation. Now, you can recall each fuzzy set basically used to express something, say high temperature or low pressure or sweet apple, whatever it is there. So, such a things in fuzzy concept, it is called the linguistic hedge, that means high temperature. The linguistic hedge, it is that okay, temperature is high, but temperature is high, that means the different temperature is high with the different membership values. Similarly, if we say the pressure is low, that means the different pressure can be termed as low, and then same pressure can be termed as belongs to low pressure or high pressure. So, here pressure low, pressure high, they are called the linguistic hedge. Likewise, there are many linguistic edge, for example, related to our age. We can define related to our age, say young, middle aged and old. So, these are the three fuzzy sets if we can define, then from these three fuzzy sets we can easily define another fuzzy set like say very young, not very young or like this one. Similarly, if the old is a fuzzy set, very old, very very old, extremely old, all these fuzzy sets. Now, the question is that how these kind of fuzzy sets can be obtained if a fuzzy set is available already with us. Here is an example, we can use or you can use the concept of concentration and dilation to do these things. Now, here for example, mu extremely old. So, if we know that mu x is a fuzzy set which is defined for the old fuzzy set and x is any elements belongs to the fuzzy set old, then any elements belongs to the fuzzy set extremely old having the membership value mu extremely old x, that can be obtained like this. So, it is basically mu old x, that is the original fuzzy sets having the membership value, and we can take x square, x square, x square. So, this basically gives the very old, this is very very old and this is basically extremely old. So, these are the different linguistics can be obtained, and here we have used the concept of concentration. Now, similarly, if more or less old, if x mu is defined for the old fuzzy sets, then more or less for k value say 0.5 we can define this one. So, it is called the dilation. Now, graphically the same thing can be plotted nicely, we can say it. Okay, here as an example, so we can write it. So, if suppose this is the fuzzy set young, then by applying the dilation we can say the very young we can define like this, another fuzzy set. Similarly, if this is the fuzzy set old, then using the concentration we can define another fuzzy set very old like this one. So, the different fuzzy sets can be obtained, from existing fuzzy sets if we follow some concentration and dilation formula. Here is few example again, mu young x is one fuzzy set defining the membership function, fuzzy set young defining its membership function as mu young x, and it is suppose defined by means of bell shape curve that we have discussed, and this is the curve. Then mu old also another fuzzy set which is defined by another bell shape curve which is like this one. Now, given these two we can define the other not young. So, not young can be defined 1 minus mu young x. So, this is another fuzzy sets, the value or membership values belongs to another fuzzy set, let the name of the fuzzy set be not young. So, this can be derived from the fuzzy set young. So, as another example, young but not too young, we can define this kind of concept. So, mu young x and it is complement of this one. So, it is young and it is not young. So, young but not young can be defined by this one. Now, regarding this kind of formulation we will discuss in details in our next lectures. So, what I want to say here that given a fuzzy set we can derive another fuzzy set easily using some mathematical computation and formulation. So, these are the things it is there we have discussed about the concept of fuzzy sets first, and then we learned about what the difference between crisp set versus fuzzy sets. Subsequently, we learned about the different membership function, that is with which we can define fuzzy sets, and then different properties in it, and how the membership function can be better mathematically expressed also we have learned it, and we will discuss about the different fuzzy set operation in our next lecture. Thank you.